Good evening, my YouTube viewers. Crystal here. I wanted to talk tonight about the Analytics Vidhaya Agriculture Hackathon. I've got another solution to it that has given me 83% accuracy on the solution checker of Analytics Vidhaya Hackathon website. I'm not formally entering the competition because I only got 83% and the highest percentage was 95%, and that's and I'm 12 points lower than the highest percentage, so I'm not going to win. But nevertheless, I wanted to show you my solution to give you a little bit of training on this particular website. This particular competition. So I put the solution on GitHub, and so you can follow me on GitHub and look at the answer if you want. So the first thing I did was I imported all of these files, and you'll see that I've done a lot of experimentation, and because I was doing experimentation, I perhaps imported a lot of libraries that perhaps I didn't need, but that's just the way it goes when you're experimenting. Sometimes you're going to put libraries you don't need into the system. And then what I did was I set up my coding. So I set up a standard scaler and I set up min-max scaler, although I wasn't sure if I was going to need it, but I decided to go ahead and set it up just in case. The next thing I did was I loaded my data sets. I loaded the train set, the test set, and the sample set. So you can see the train data set. And the nice thing about this data set is it is all numeric. I did not have to convert anything from an object to a number, which was nice, but I did have to convert like the number of weeks used to an integer. And now you've got your test site. The test site is the same format as the train site, except for the fact that it's missing the crop damage column. Now the crop damage is your target column. It's your Y value. It's your dependent value. And the targets are going to be 0, 1, or 2. So 0 is going to be alive, 1 is going to be other damage, and 2 is going to be damage via pesticides. And then I called up the sample sub, and on the sample sub, you can see that what Analytics Vidhaya wanted was an ID number and the crop damage, it being either a 0, 1, or a 2. So the next thing I did was I called up info on train and also info on test. And you can see the ID was an object, but we weren't going to use that for the predictions. And number of weeks used was a float. And I think that I had to convert that to an integer. So we described train. So if you wanted to use any standard values, you could see the standard values. And we described test. We checked to see if there were any null values in train or test. And there were null values in number of weeks used in train and test. So what we had to do was we filled those values out with the median and the train and the test file. And then the next thing that we did was we checked to see if there were any other null characters in the train and test file. And no, there were no more null characters. And then what we did was we checked the train file and the test file. I did a heat map so you can see how the crop damage, which was the Y column, relates to all of the other columns. And then what we did was I did a group by on the crop damage so you can see how the crop damage relates to all of the other columns in the group by section. And then we did a disk plot with Seaborn. And the thing that we found out is we had a lot of zeros, a little bit of ones and even less twos. And what that caused was that gave an uneven system of categories. And because it gave an uneven system of categories, then it meant that in the training process, it may not have picked up the number 2 values. So that was something that needed to be corrected. And while I was experimenting on this data set, one thing that I noticed, like logistic regression in particular, it didn't pick up any 2s. So we did a violin plot of insects, so you can see the insects that were covering the crops. Mostly they were less than 1,000. And so we can see all the insects, the estimated insect count. And then what we did was we did a violin plot on the crop frequency. So there was only 2 crop types. And there were more of crop type 0 than there were of crop type 1. The next thing we did was we did a violin chart on the soil frequency. And there were 2 soil types as well. And there were more soil type 0 than there was soil type 1. And the next thing we did was we did a violin chart on pesticide frequency. And there were 3 types of pesticides. And the third type was the most used pesticide, and then the second type, and then the first type. Then we did a violin chart on the dosage frequency, so you can see how many times pesticides were administered to the crops, and we did a group by on that, and you see they had 20 different dosages that they could have given the crops, with the first number starting with 0. And then we did a violin chart on the usage frequency, and you can see we had to convert that to an integer because that's what the algorithm wanted to see. The algorithm wanted to see integers. And so you can see here we had the number of weeks used. We had 64 different numbers of the number of weeks used. And so, so what I did was I sort of made a little bit of a mistake, but it wasn't a major mistake. I converted the columns to integers twice, but that doesn't matter because, at least we know it got done. The next thing we did was we did a frequency chart on the quit, the number of weeks that they had quit using the pesticides. And you can see most of them were around 0. And then we did a group by, which the 0, that pretty much confirmed it. The number of weeks quit, 0 was the largest portion. And then we did a box plot on the season, and they only allocated 3 seasons to the crops. And I don't know if it's because they don't do anything in the winter season, but they only allocated 3 seasons to the crops, with the second season being the most, and the first season being the second to the most, and then the third season being the least. And then after we prepared the data, that was the data preparation phase, what we did was we set up our features. So the features is every column except for the ID and the crop damage. So we also set up our Y value. Our Y value is train labels, which is NP array, train crop damage values, reshape -1, 1, D type, float 32. And so the next thing we did was we defined our X and Y and X test variables. So X is train features, Y is train labels, and X test is test features. The next thing we did was we scaled the data. So I scaled it on min-max, and min-max was supposed to give you a value of 0 to 2. So I scaled X, Y, and X test on min-max. Then what we did was we did use SMOTE to take care of the fact that number 2 didn't have hardly any occurrences. And what SMOTE does is SMOTE inserts synthetic sampling into the train file. And so X resampled, Y resampled equals SMOTE, fit resample X and Y. And then the very next line, what we did was we took our train set and we broke it up into a train set and a test set using train test split. So you broke it up into train X, val X, train Y, val Y, and train test split was X resampled, Y resampled, random state equals 1, and test size equals 15. The next thing we did was we checked the shapes of our training file. So X shape was 189,306 with 8 columns. Val X was 33408 with 8 columns. Train Y was 189,306 with only 1 column, but it was an array. And val Y was 33408, and it was just an array. So we set up our model as XGB classifier, and then we fit the model with train X, train Y. And we set up Y pred equals CLF predict val X. And then what we did was we checked the accuracy of the model, which was 62%. And then what we did was we used some special algorithms particular to XGBoost to prepare the data to be formatted in XGBoost. We set up our parameters. And then what we did was we used the training data to build the model. The next thing we did was we did a projection on D-test, and D-test was the built model using the special formulas for XGBoost. And then the next thing we did was we tested Y predict equals Y predict flattened. So we flattened Y predict and we flattened val Y, and we put that into a data frame where you can compare the actual values to the predicted values. And then the next thing we did was we scored it. So accuracy score was 62.66%. F1 score was 61.46%. Recall score was 62.66%. And then we created a confusion matrix. And the next thing we did was we created another matrix so you could see how many Y values were predicted. And so the pesticides was number 2, and that was the one that they didn't have hardly any of. And what they had done was they had used synthetic information to train the data to bring the number of 2s up. So then we tested our accuracy, and our accuracy is 62.66%, and we created a classification report. And this model, we dumped the model into a file called dump.raw.txt. And then so what we did was we predicted on D-test. So, and then that gave an array. And the next thing we did was we converted this array into, we further formatted the array so it could be used for XGBoost. And then we printed our precision, which wasn't very good. I don't think it was 11.272%. Save the model into a pickle file. I've never used a pickle file, but basically, if you want to reuse the model again, then what you do is you save it into a pickle file, and then you can come back and pick up the model and put more data in it. But I've never used a pickle model, so I can't tell you how it works. We plotted a chart to visualize the data, plotted a chart to test the features, and now what we're doing is we're testing on the test file. So we set up preds and it output an array. And so final preds output an array 2. We had to prepare the data to be sent out for submission. And so we tested the shape of test ID, and final preds to make sure that they were the same shape. And then we put that data into a data frame, and we called it ID, which was test ID, and crop damage, which was final preds flatten, because they had to flatten the file before it could be submitted to Analytics VidHaya. We saved the file into a file called submission.csv, and submission.csv is what I submitted to Analytics VidHaya, and I got an 83 point something percentage, which was pretty good considering the highest percentage was 95. And so what we had to do was, in order to get an 83%, we had to use XGBoost, and we also had to use SMOTE to put synthetic information into the train file for testing. So that concludes this presentation, where I've given you the solution to the Analytics VidHaya Agriculture Hackathon. And anyway, you know where I am. I'm on GitHub. So I'll just call it up to the very top of my GitHub account. So if you want to track me down, if you want to do a search on GitHub to find my name, then you'll be able to find the agriculture repository and find the files that I created with the solution to this problem. And you're more than welcome to use the solution. It's not a winner. I mean, you're not going to win the competition with it, but it will get you on the leaderboard if you want to study it, and it'll give you a little bit more understanding of how to solve this problem, because I believe that I wrote it in a very logical way, because I'm just learning myself. So that's it for this presentation. If you like my solution, please like, subscribe, and share. If you like the work I'm doing and you want to make a donation, I've got my email address to my PayPal account in the comment section down below. I don't have enough subscribers, so the only way I can make money on my YouTube account is to ask for donations. Thank you so much for watching this video, and I look forward to making the next one for you.